Hello, everybody. Okay, so we're going to get started on chemistry finally. So, our first thing we've got to talk about in this unit is the classification of matter. So, what is matter exactly? So, first, I want to point out that it's going to be making a flow chart for you all. Make sure that you remember this. I'm also going to add it into your notes. That way, it's pretty easy for you, but you're going to need to know this for sure. Matter is anything that takes up space and has mass. Matter is either a substance or a mixture. A substance is all particles in matter are identical, so they're fixed composition. A mixture is two or more substances physically combined. It's a variable composition. All right, next, there are two types of substances. The element, which is the simplest form of matter from which more complex substances are made, which those are the ones listed on the periodic table. All of the atoms that make up an element are alike. Example would be helium. So that's why there's a picture of balloons. Then you have elements, like I said, that they can exist in a couple different ways. The first one is something like helium, argon, and neon are stable as an individual atom. So something like this, so they can be by themselves. They don't have to be combined constantly with other things. And then there's also things that need to be bonded together. That's oxygen, nitrogen, and hydrogen that are only stable as two atoms bonded together. So they look like this, O2, N2, and H2. Okay, let's talk about compounds. So compounds are two or more elements chemically combined in a fixed proportion. So these things can be broken down, but only by chemical reactions. And they have properties different than the elements that make them up. So an example would be table salt, water is a good one, and sugar. Those are all different elements combined. So substances on a molecular look, we're going to look at the difference between an element and a compound. So an element is just one substance. It's the simplest form. Even when it's bonded with itself, it's still its simplest form. So oxygen, O2 is an example. And then a compound is two or more elements chemically combined, like CO2 here. So that's carbon dioxide, and that's what it would look like. There are two types of mixtures. We're going to hit the other side here. We have homogeneous. Now, this is my one preface. If you're going to use this word, you need to use the whole word. We're learning a new language in science. That means you need to start using it correctly. You need to say the entire word, not the shortened one. That can be offensive. So the entire word needs to be said when you're describing this type of mixture, okay? Homogeneous mixtures are components that are evenly distributed out on a microscopic level. Solutions are like a subset of that. It's when one substance is dissolved into another. Those are considered homogeneous mixtures. So things like lemonade, tea, those usually appear blended. You can't really see where one thing starts and another thing stops. So like I said, lemonade, tea, coffee, as well as bleach would be considered a homogeneous solution. Let's talk about heterogeneous. So heterogeneous substances in the mixture are not evenly spread out. So it's really obvious. They can start to separate out over time. So a really good example of this is salad dressing that involves any sort of oil or anything. It starts to separate. Old paint starts to separate. We all know about cereal because obviously that's very much two separate things. You're putting milk into cereal. And another example is peanut butter. Old peanut butter does start to separate over time. If you've never seen that, it's interesting. Okay, next let's look at the molecular look of a mixture. So let's look at the difference between a homogeneous versus a heterogeneous mixture. So homogeneous means an even distribution or the same. So you'll notice in this picture right here, this is supposed to be salt water. You've got your water molecules, and there are 5 of those. And then there's salt, which is here, this like light blue and tan. There's 4 of them. That doesn't mean it has to be the exact same ratio of molecules. It just means that for every however many of a certain element than there or compound than there is of the other. So, and then you have a heterogeneous mixture. It means an uneven distribution or it's different. So an example would be salad dressing. You can see all sorts of different compounds in here. They're not evenly distributed. I mean, you've got some random atoms just hanging out. So, I mean, they're part of the salad dressing, but that would be a heterogeneous mixture. And then this is the flow chart that I was talking about that you guys need to know. I will have you guys do this in your notes as best as you can. I will do what I can. So if you guys don't have any other questions, just let me know. But you need to add right there to help you kind of understand better what each of those means. So substance is a fixed proportion, mixture is physically combined, element is on the periodic table, compound is chemically combined. For mixtures, heterogeneous means different, homogeneous means same. All right, let me know if you guys have any questions.